Alright, so in this video we're going to tackle an analytical geometry question from November 2015, question 3. So it's always important to read the information and just make sure everything is present on the diagram, and if it's not, just to keep a note of it as it might be useful at some point during the question. So in the diagram, C is a point on the y-axis. So here's C on the y-axis such that A 0 and 4, B 4 and negative 4, and D, B, C and D negative 4 and 2 are vertices of a parallelogram. So this shape is given as a parallelogram, and that's been marked using opposite sides are parallel. This side is parallel to this and this is parallel to that. K is a point over here, is the point 0 to negative 2 and a quarter. And L is a point on AB such that KL is parallel to CB. So here's CB, here's KL. These two lines are parallel. Okay, so everything has been marked. Now let us begin. Calculate the length of diagonal DB. When you say length, we're talking about the distance. So we need to use the distance formula. So the length or the distance of diagonal, let's just put 3.1. So the distance of diagonal DB is equal to the square root. Our formula is x2 minus x1 squared plus y2 minus y1 squared. And that's equal to, now our coordinates D and B are over here. We can say that coordinate D comes first when you read from left to right. So that'll be my x1, my y1, and this will be my x2 and my y2. Right, now that we know that, let's go ahead and fill in our formula. So x2 is going to be 4 minus x1 is negative 4, so fill that in, squared, plus y2 is negative 4 minus 2 close squared. Alright, so that's the square root of, so we got 4 plus 4, which is going to be equal to 8 squared, plus this one you've got negative 4, negative 2, that's negative 6 squared. And the square root of that answer, your answer for the distance is basically going to be 10 units. Alright, so the distance from D to B is 10 units. The second question, the coordinates of M. So 3.2, the coordinates of M, and M is the midpoint of D and B. So you want the midpoint of D and B. So the midpoint, there's two parts to it. There's an MX and there's an MY. MX is equal to x1 plus x2 over 2, whereas my is equal to y1 plus y2 over 2. Your x1 plus x2, so it's going to be 4 plus negative 4 over 2. And your my, that's going to be y1, which is 2 plus negative 4 over 2. So that's going to be 0 over 2, so it's going to be 0 and negative 1. Alright, so the coordinates of the midpoint of DB is going to be 0 and negative 1. 3.3. Calculate the gradient of AD. So gradient is small m. Gradient of AD is equal to y2 minus y1 over x2 minus x1. In this case, now we're looking at AD. So we don't need those x and y values anymore. So A and D comes first. So this is going to be 1 and 1. That's going to be 2 and 2. My y2 value is going to be 4. My y1 value is going to be 2. X2 value is 0. And x1 value is negative 4. So my gradient should be 4 minus 2 is 2 over positive 4, so that should be a half. The gradient of AD is given as a half. So we have the gradient of AD. Alright, So the next question says, prove that AD is perpendicular to AB. Now, in order for them to be perpendicular, the gradient of AD times the gradient of AB have to equal to -1, right? So they have to equal to -1. That's if they are perpendicular. So we just need to see if that happens. So for now, let's take that away. What's the gradient of AD? We're just gonna test it out. So gradient of AD is a half times. What's the gradient of AB now? So AB, we need the gradient of AB. So you can say m of AB is equal to y2 minus y1. So -4 minus 4 over x2, which is 4 minus 0. So that's -2. So the gradient of AB is -2. A half times -2 is going to be -1. So because it is -1, therefore we can say m of a, therefore MAD times MAB is equal to -1. Therefore AD is perpendicular to AB. 3.5. Give a reason why the parallelogram is ABCD is a rectangle. So what are the properties of a parallelogram as compared to a rectangle? What's the difference? The only real difference here, the only real difference between the properties is that, or they have, everything is the same except a parallelogram's angles, opposite angles are equal, whereas a rectangle, all angles are equal to 90 degrees. By proving that AB is parallel to AD, you've already proved that there's a 90 degree, and that would automatically make every angle there 90 degree. So we can say that all angles are 90 degrees. 3.6. Now this is an important question, alright? So KL. So KL is here. They want the equation of KL in the form y is equal to mx plus c. So they want the equation of this. Now, what often happens here is when they want the equation of a straight line, in these questions, they don't give you much. They just give you the line where it is, and they just give you 1 point. And they mention something about which line it's parallel to or perpendicular to, and you're expected to get the equation using that information. So in the case of KL, we know it's parallel to BC. So what does that mean? That means so firstly, we know that KL was said to be parallel to CB. Parallel to CB. We can therefore say that the gradient of KL is equal to the gradient of CB. Alright, the gradient of CB. But we already know that the gradient of CB is equal to the gradient of AD. So we already know that the gradient of CB is equal to the gradient of AD. So the gradient of KL therefore has to be a half, which is the gradient of AD. So we know the gradient of KL. So we use the formula y1. Well, you can just use it from y equals mx plus c, alright? Mx plus c, and then what you do here is you substitute your gradient for m. So you'll say y is equal to a half x plus c. Now at this point you need a coordinate in order to solve for c, alright? So in this case you're looking at KL, you need a coordinate on this line KL. Alright, so in this case the coordinate you have is k0 and 2, -2.25. So you have 0 and -2 and 1 over 4. You can substitute this coordinate to get the value of c. So if you put -2 and 1 over 4, and that's equal to a half x plus c, and then you solve it, eventually 0, x is 0, and then you solve for c, you're gonna get -2 and 1 over 4. Now that you usually do, but in this case you didn't need to do that because k is a y-intercept. The reason I showed you the substitution method is because sometimes you won't have the y-intercept. You might have a number here. then you need to sub it in full and solve for c. Now once you're done with your c value, your equation is y is equal to a half x minus 2 and 1 over 4. And that's the equation of the straight line KL in the form y is equal to fx plus c. Now lastly, they want the coordinates of c. Alright, so how are you going to get the coordinates of c? So let's have a look here. C is the a point on the y axis. So firstly, what's our coordinates on the y axis? What coordinate do we know here? We know there's a x and a y coordinate, but if it's on the y axis, that means your x coordinate is 0. You just need to find the y value. And we already know the gradient of this line BC. So we can say that the gradient of BC is equal to y2 minus y1 over x2 minus x1. The gradient we know is 1 over 2, and that's equal to y2 minus y1. So this would be 2 and 1. Negative 4 minus y over 4 minus 0. So that'll equal to minus 4 minus y over 4 equals to a half. And then you can cross multiply. So 4 is equal to negative 8 minus 2y. Then 2y is equal to negative 12. Divide both sides by 2, and y is equal to negative 6. And then so your coordinates are going to be 0 and negative 6. Let's just check if we got that correct. Yeah, so that's fine. So your coordinates for C are 0 and negative 6.